Have you ever wondered how investigators catch a hacker who seems to just vanish into thin air? Well, it's not magic, it's digital forensics. And today, we're going to pull back the curtain on this fascinating world. Forget the dry, technical manual stuff. We're going to treat this like the thrilling detective story it really is. So let's start with a big mystery, right? An attacker gets in, they do what they came to do, and then they meticulously delete every single file they used. The digital crime scene looks spotless. So the question is, how in the world do you prove they were ever there to begin with? That's the exact puzzle we're going to piece together today. You know, every investigation, it always starts at the scene of the crime. For us, that's a compromised computer. And what we need to find are the digital equivalents of fingerprints, of footprints, maybe even the DNA that our intruder left behind. Now, to make this feel real, we're going to focus our entire investigation on one primary person of interest, a suspicious little file named pect.exe. Our mission, to prove what this file did, even if the file itself is long, long gone. Okay, let's dive right in. Any good detective, what's the first thing they look for? Footprints, right? Proof that someone was physically at the scene. Well, in the digital world, we have something that's strikingly similar. It's called a prefetch file. Now, Windows creates these little helper files basically to make your programs launch faster. But for an investigator, a prefetch file is like a clear, muddy footprint in the digital soil. It's a solid record that a specific program stepped onto the system. And here's the crucial point. Finding the prefetch file for our pect.exe, well, it doesn't just suggest it was there, it proves, with a really high degree of confidence, that the program was actually executed. It was run. It can even tell us what other files or modules, think of those as shared toolkits for programs, it loaded up. This is our smoking gun for the action itself. But of course, there's a twist. Our attacker is smart. They know about these prefetch files. So as we're doing our analysis, we notice something odd. The specific prefetch file for executable.exe has been surgically removed, while all the others around it are totally untouched. So does that mean we've hit a dead end? Is the trail officially cold? Honestly, not even close. Because in forensics, you have to remember this. The deliberate act of hiding something is in itself a massive clue. An attacker who selectively deletes one single footprint among hundreds, well, that's like a giant flashing neon arrow pointing right at it. They've basically just told us exactly what they don't want us to find. All right, let's move on to our next clue and see how this story builds. Since that footprint was intentionally wiped away, we're going to check the system's logbook, a record of things the computer has seen even if they aren't there anymore. This artifact is called the Shim cache. The best way to think of it is like a librarian who jots down the title and location of every single book, or in our case, program, that's ever been on the shelf. Its main job is to help with application compatibility, but for us, it's a memory bank. Now, what's really fascinating here is the critical difference from a prefetch file. The Shim cache proves that our file, pect.exe, existed on the system. It can even tell us the full path to exactly where it was located. But, and this is a big but, it cannot prove it was ever executed. It saw the file, but it didn't see the action. Okay, let's recap. The attacker's attempt to hide their footprint hinted at execution. The logbook proved the file existed. But we still need to confirm its definitive identity. And for that, we need the file's official ID card. And we find that in something called the Amcache. This is another part of the system that acts like a super detailed inventory system. It takes note of programs that have been run and records a whole bunch of information about them. And here's where we strike gold. The Amcache gives us the file's unique SHA-1 hash. That's a special code generated from the file's contents, and it acts like an unforgeable digital fingerprint. It also records things like the program's compile time. And here's the brilliant part. This record often survives reboots, and, most importantly, it's still there even after the original file gets deleted. We now have our file's unique identity locked in. Okay. We've collected our clues. We have a wiped footprint, an entry in a logbook, and a detailed ID card. It's time to lay them all out on the investigation board and see how they tell one single, coherent story. This is exactly how investigators build a case that's incredibly hard to refute. The deleted prefetch file is our evidence of the action. The Shim cache proves the file was present and gives us a location. And the Amcache provides that definitive identity through its hash. See, no single artifact tells the whole story, but when you put them all together, they become undeniable. So now, let's zoom out. Finding one malicious file? That's great. But modern defense isn't about playing whack-a-mole. The real goal here is to understand the attacker's entire strategy, their playbook. And this represents a really crucial shift in cybersecurity. We're moving away from hunting for what we call indicators of compromise, or IOCs. Think of those as file names and hashes, things that are super easy for an attacker to change. Instead, we focus on understanding their tactics, techniques, and procedures, or TTPs. This is their behavior, and that's much more consistent. And here's why that's so important. An attacker can change their tools, their servers, their file names every single day. But their core methods, how they move through a network, how they hide, how they steal data, those behaviors change very, very slowly. If you focus on the behavior, you get ahead of the next attack, not just the last one. So how do we even begin to categorize all these behaviors? Well, we use a globally recognized encyclopedia of hacker techniques called the MITRE ATTK framework. It breaks down an entire attack into stages, like execution or defense evasion, and it lists all the known ways that attackers try to accomplish those goals. It gives the entire security community a common language to talk about this stuff. And that really is the ultimate point of our whole investigation. We take our clues, like that deleted Prefetch fail, which maps perfectly to the defense evasion category, and we connect them to this larger playbook. By doing this, we don't just solve the case of pect.exe. We start to understand our adversary's patterns, which allows us to build defenses that can actually predict and block their next move. Which, of course, leaves us with one final, very important question. We've just learned how to trace these digital shadows, how to read the attacker's playbook. Now that we know the rules of their game so intimately, the real challenge becomes, how do we start to change those rules in our favor?